Hey guys, Dr. B. So now we're going to get a little bit into amino acid or protein multiple sequence alignments. And this is one I grabbed from a book. I think it just makes sense because if you need to refer to um, it, especially with case study 4.2. So let's take a look at what this is. First of all, the colors mean things, and I'll define what those are, but different protein multiple sequence alignment software use different colors. So this isn't a universal situation, but in this case, as you know, amino acids fall under all kinds of groups depending on how specific you get. So basically, in this case, the yellows are the small nonpolars, the greens are hydrophobic, the magentas are polar, the reds are negatively charged, and the blue is positively charged. And so that kind of gives you a really good idea of what's happening at the amino acid level and where there's areas of conservation and where there might be missense mutations, some of which might matter, some of which might not. And to give you an example of that, you can see here that right now, right about here, 23. Yeah, it is 23. Yeah, you can see here we have P for proline, L for leucine, and even though that those are different amino acids, those are both hydrophobic, so that's not a relatively huge deal. As you can see, we have a couple other things that are definitely different colors here. We have arginine right here, and then excuse me, we also have alanine up here. And so alanine is definitely not the same color. And the reason why is that's nonpolar. And then the R, which is the arginine, is a positively charged amino acid. So that would, in all likelihood, these would have much different effects on the structure and potentially therefore the function of the protein at that particular location. So that's how you would kind of interpret these. And what else we can see sometimes is areas of conservation, areas where there's no matter what organism it is, you can see these organisms that we happen to have conserved regions. And this is one right here that's a conserved region amongst all the organisms. And then we have some other areas that are not conserved, like right here is clearly not conserved. So those, of course, would have to do with the structure of the protein in that organism and its role in whatever it does. So I just wanted to kind of give you a really, I guess, kind of quick overview of what this multiple sequence alignment is. There's all kinds. We're going to work on one called Clustal Omega, where you guys are going to organize a bunch of these as well. So there's another way I'm going to show you real quick to look at these amino acids in a relatively quantitative way. As you can see, this looks very similar to what we just saw, but it has, first of all, there's different colors, and that's perfectly fine. Whatever sequence alignment software will have its own indicator of colors, and you can change them sometimes as well. But what's of interest here is what's on the top, and you can see here that this is called an amino acid sequence logo. And basically what this does is it gives you just a visual of the relative amount of the amino acid compared to any other ones that are there. So you can see here, this one, every one of them that is an amino acid is an M, so therefore it's the entire height. But in the second residue here, we have all S's, all serines, and then one methionine. And so there's the S and there's a little M. So that just kind of gives you a relative idea of the relative quantity. And you can see here, obviously, we only have one of the sequences, Pseudomonas acidophila, strain AT. And that has residues here where the other ones don't, therefore it's really short. So that's just kind of interpretation of how you can read these.